Our sun has been humanity's faithful companion for 4.6 billion years. Every morning it rises, bathing Earth in light and warmth, powering photosynthesis, driving our weather systems, and keeping us alive. It's steady, predictable, reliable. But what if that changed? What if tomorrow morning you woke up, stepped outside, and instead of seeing our familiar yellow star, you witnessed something far more terrifying? What if the sun went supernova? Now, before we dive into this cosmic nightmare, let me be clear about something. Our sun cannot go supernova. It's physically impossible. The sun simply doesn't have enough mass. But we're not here to talk about what's realistic. We're here to explore what would happen if the impossible became reality. And trust me, you're not prepared for what's coming. Picture this. It's 6:47 a.m. on a Tuesday. You're getting ready for work, maybe grabbing coffee, scrolling through your phone. Then suddenly, every window in your house explodes with light brighter than 1,000 welding torches. The sky isn't blue anymore. It's white. Pure, blinding white. Your first instinct might be to look outside, but that would be the last mistake you'd ever make. Because what you'd be staring at isn't the sun anymore. It's a stellar explosion unleashing more energy in a few seconds than our sun produces in its entire 10 billion year lifetime. But let's back up for a second. What exactly is a supernova? It's the violent death of a massive star, at least 8 times heavier than our sun. When these giants run out of nuclear fuel, their cores collapse in less than a second, then explode outward with unimaginable force. The explosion is so bright, it can outshine an entire galaxy containing billions of stars, and we're about to put one of these monsters exactly 93 million miles from Earth. The moment our sun goes supernova, several things happen simultaneously, and none of them are good for us. First, the light. Within 8 minutes and 20 seconds, the time it takes light to travel from the sun to Earth, our planet gets hit with a wall of electromagnetic radiation. We're talking about light roughly 5 billion times brighter than normal sunlight. To put that in perspective, it would be like standing next to 5 billion suns all at once. The first victims wouldn't be humans. They'd be our satellites. Every piece of technology orbiting Earth would be instantly fried by the electromagnetic pulse. GPS dies. Communications go dark. Weather satellites vanish. The International Space Station, if anyone happened to be aboard, would become a tomb floating in space. But honestly, the astronauts would be the lucky ones. Their deaths would be quick. Down on Earth's surface, that initial flash of light would be visible even on the daylight side of the planet. The sky would turn white, then blue-white, then an eerie green as different atmospheric gases got excited by the radiation. Anyone looking directly at this spectacle would be instantly and permanently blinded. But even if you had the sense to look away, it wouldn't matter much, because this is just the beginning. Within minutes of that first flash, Earth's atmosphere would start heating up. The ozone layer, our protective shield against ultraviolet radiation, would be completely destroyed. But that's not the real problem. The real problem is what happens to the nitrogen and oxygen in our atmosphere when they get hit with this level of radiation. They start forming nitrogen dioxide, the same gas that gives smog its brown color. Except now, it's forming everywhere, all at once, across the entire planet. The temperature begins climbing, not slowly like climate change, but rapidly. Within the first hour, surface temperatures would rise by dozens of degrees. Plants would begin wilting. Lakes and rivers would start steaming. Anyone caught outside would experience something like being slowly cooked in an oven. The lucky ones would find shelter, but shelter won't help for long. As that wall of radiation continues pounding our atmosphere, something even more sinister begins happening. The air itself becomes toxic. Those nitrogen dioxide compounds we mentioned, they're poisonous. Breathing becomes difficult, then painful, then impossible. But most people won't live long enough to suffocate. Because by this point, the real killer is making its approach. Remember, a supernova doesn't just produce light and heat. It produces matter, lots of it. The star literally explodes, hurling its outer layers into space at speeds of up to 30,000 kilometers per second. That stellar debris, superheated plasma containing elements forged in the heart of a dying star, forms what astronomers call a shock wave. And it's heading straight for us. This isn't like a shockwave from an explosion on Earth. This is a wall of ionized gas and cosmic particles traveling at roughly 10% the speed of light. When it hits Earth's magnetosphere, our planet's magnetic field, the collision would be unlike anything in our planet's history. The northern and southern lights, normally confined to polar regions, would explode across the entire sky in brilliant sheets of green, red, and purple. It would be beautiful. It would also signal the beginning of the end. The shockwave would compress Earth's magnetosphere, squeezing it like a balloon. Our protective magnetic bubble, which normally extends about 65,000 kilometers into space, would be crushed down to maybe a few thousand kilometers above the surface. The surface. With our magnetic shield compressed, Earth becomes a sitting duck for the full fury of the supernova. The plasma wave, carrying particles accelerated to near light speed, slams into our atmosphere with the force of a cosmic sledgehammer. The impact generates temperatures exceeding 100 million degrees Celsius. That's 6 times hotter than the core of the sun on a normal day. The atmosphere doesn't just heat up anymore, it starts getting stripped away. Imagine Earth as a peach and the shockwave as a cosmic peeler, tearing off layers of our protective atmospheric skin. First goes the upper atmosphere, then the stratosphere, then chunks of the troposphere where we actually live and breathe. Within hours, Earth begins losing the very air that keeps us alive. But the atmosphere isn't going quietly. As these superheated gases get ripped away from our planet, they create their own light show. The entire planet becomes wrapped in a glowing cocoon of escaping air, turning Earth into a miniature comet with a tail pointing away from the supernova. From space, our planet would look like a blue marble trailing a ghostly white streamer millions of kilometers long. Meanwhile, on the surface, the few remaining pockets of humanity face a choice between impossible options. Stay outside and get cooked by radiation levels thousands of times higher than a nuclear blast. Hide underground and slowly suffocate as the oxygen gets sucked into space. Either way, the outcome is the same. The deepest bunkers might buy you a few extra days, maybe weeks if you're incredibly lucky. But you can't hide from the fundamental problem that your planet is being sterilized from space. And we haven't even talked about what happens to the oceans yet. Remember, water boils at 100 degrees Celsius under normal atmospheric pressure. But as our atmosphere gets stripped away, the pressure drops dramatically. Water starts boiling at lower and lower temperatures. The oceans don't just heat up, they begin evaporating explosively. Massive clouds of superheated steam rise into what's left of our atmosphere, only to be blown away into space by the relentless stellar wind. The weather during these final days would be unlike anything Earth has ever experienced. Imagine hurricanes powered not by warm ocean water, but by the fundamental destruction of the planet's climate system. Winds reaching hundreds of kilometers per hour, carrying not just rain and debris, but the very molecules of our dying atmosphere. Lightning storms crackling through air so thin it barely conducts electricity. And through it all, that terrifying light from the supernova, now dimming slightly, but still bright enough to illuminate the apocalypse in stark detail. Plant life dies first, unable to photosynthesize in the radiation-soaked environment. Then the animals, starting with the most sensitive species and working up the food chain. Marine life gets a brief reprieve as water provides some protection from radiation. But as the oceans boil away, even the deepest sea creatures face extinction. Within weeks, Earth transforms from a vibrant blue planet teeming with life into a scorched, airless rock more closely resembling Mars than the world we once knew. But here's the truly mind-bending part. Even after all this destruction, even after our atmosphere is gone and our oceans have boiled away into space, the supernova isn't finished with us. That initial shockwave was just the opening act. The real show is the expanding bubble of stellar debris that continues growing outward from where our sun used to be. This supernova remnant, a shell of superhot gas and exotic particles, will keep expanding for thousands of years. Earth, now a dead rock orbiting the neutron star or black hole left behind by our sun's explosion, sits directly in the path of this expanding cosmic graveyard. Over the following millennia, our planet gets sandblasted by particles moving at incredible speeds, slowly eroding whatever's left of the surface, Mountains get worn down to rubble, continents get scoured flat. Eventually, even the rocky core of our world starts getting chipped away, atom by atom, until there's nothing left but cosmic dust mixed in with the expanding remnants of what used to be our solar system. The other planets don't fare much better. Mercury and Venus, being closer to the supernova, get vaporized almost instantly. Mars loses its thin atmosphere in minutes and becomes another dead rock. The gas giants Jupiter and Saturn actually put up more of a fight. Their massive atmospheres absorb some of the initial shock, and for a brief moment, they might even look more spectacular than ever, their cloud bands glowing with auroras visible from billions of kilometers away. So, there you have it. In less than 24 hours, humanity's entire story comes to an end. 8 minutes for the light to reach us, a few hours for the atmosphere to start cooking, days for the oceans to boil away, weeks for the last traces of life to disappear.